Assalamu alaikum. I am Ayesha Akter. Now I am going to present my presentation with Bayes algorithms and clustering work in Open Refine. This presentation is designed for Mr. Anajit Alim Russell sir, who is our Advanced Syntactic Pattern Recognition course instructor, and course code is CSC 713. Let's start from the next slide. Now Open Refine. First, we have to know about Open Refine. It called Google Refine, and before that the Freebase Greek works. Is a standalone open source desktop application for data cleanup and transformation to other formats. The activity known as data wrangling, it is similar to spreadsheet applications. It behaves more like a database. It provides a set of tools to allow you to identify and amend the messy data. So in this presentation, I will tell about how each of the algorithms in OpenRefine works and how cluster works in OpenRefine. So one of OpenRefine most powerful features is the clustering function. With the support of several types of key collision and nearest neighboring algorithm, the clustering function can help us to identify inconsistencies in our data, from misspelling to non-standardized value format or input error. Then clustering works by using what is called fuzzy matching one of the value within a chosen column, using the algorithms of our choice to determine if possible cell values look similar enough to be possible matches. The algorithms supported by OpenRefine are of two types: key collision as well as the nearest neighbor. So key collisions have 6 parts and nearest neighbor have 2 parts. Clustering work in OpenRefine, and folder path should be visible in this video. So yeah, this is where the data file should be kept. Now I'm going for practical. First, I will do our data set where I downloaded and kept in the showing way on my laptop location. Now I will go git bash shell. Here it is, to see my downloaded data. Type pwd where I can see my current directory pwd, then ls, it means list of file. I will select desktop folder where I kept information that I will use and import for OpenRefine. Here cw desktop, again ls cw 211. Here is it's my id. ls. See here I downloaded this file and then name this new dot text. So if I can check, so cat new, see here is the data. Next I will go the OpenRefine exe file. It's opening. So here we can import the data file lots of way, like from the desktop choice file, web addresses. Here I will put the link, then it will download it. URL address, clipboard, databases, Google data, etc. But I will use the downloaded file where I download from the website before. Here see here the location, desktop, my roll number, and click the open button. Then next, uploading data, and also click the create project, then it will create it. Done. And see, we will see 1001 rows. Before talk, I will explain how each algorithm work in OpenRefine and how works in OpenRefine. Then first I will go in the before I included that in key collision. There are 6 algorithms that are very fast and can process millions of cells in second. There are 6. First one is fingerprint. See here, I will go the author, edit cells, cluster, and edit section. Then see, before I talked key collision, there have 6 part, fingerprint, angiogram, etc. Then I will check this, nothing, also nothing, then close. Before I check what actually I want, it is the edit cell edit, publisher text here. See here I will get. So first I will tell about this. It is the least likely to produce false positive, so it's good place to start. It does the same kind of data cleaning behind the screens that might think to do manually. Fix white space into the signal spaces, but put all upper cases later into lower cases. Discard pronunciation, remove discard from characters, split up all strings words and short them. Example, publisher column that I already entered here, and cell column. Look, see, if I go the browser, the screen cluster, here I can edit. Here there have 2 space, so if I delete 1 space, then click apply, then here the same 96. Again I will do the same previous things, space. Yeah, so we can clear about the fingerprint sections. Now we will go for the next algorithm. Here we can use the authors, cell cluster algorithms. Look, key collision function key, we consider n-gram fingerprint, key function n-gram size 2. Now explain. It allows you to set in n value to whatever number we would like, and will create n-grams of n size, alphabetic them, then join them back together into a fingerprint. For example, 1 gram fingerprint will simply organize all the letters in the cell into alphabetically. Like here, if we click the 1, see here. Now click the 2. So a 2 gram fingerprint will find all the 2 character segment, remove duplicated alphabetically them, and join them back together. This can help match cells that have types or incorrect space. The higher the n values and the fewer cluster will be defined with n grams. Keep the eye out, okay, what mismatched values that are near anagrams of each other. Then the next part is metaphone. Actually, it is a part of phonetic fingerprint. The next 4 methods are phonetic fingerprints before I included. So they identify letters, the sound name were pronounced out loud, and assesses text value based on first click this here. So actually they are great for spotting mistakes made by not knowing the spelling of words or name after hearing it spoken aloud. So here metaphor 3 fingerprint is an English language phonetic algorithm. For example, is here. Also the next closing phonetics. Here also see it's another algorithm, but for German pronunciation. Next, the Diatic's Mokotov algorithm. So it is also the phonetic algorithms for Slavic and Yiddish words, especially names. Next, the algorithm is Bader-Moros. So Moros is a version of Diatic Mokotov that is a slightly more strict algorithm. And next we will go for the method nearest neighbor. Here also we can see the 2 algorithms is there. So when defined, it uses the blocking method, a certain amount of similarity. The default is 6 for the 6-character string of identical characters, and then runs the nearest neighbor operations on those stored groups. So first, Levenstein, its radius is 1. Here, already I click it. Actually, it distance counts the number of edits required to make one value perfectly match another. As like the key collision methods above, it will do the things, the changes of uppercases and fix this. So in this character, and that gets the change count as one distance. Here this. Next, PPM. Actually, PPM means prediction by partial matching. It uses the compression to see whether two values are similar or different. In practically, in this method is very lax even for small radius values and tends to generate many false positive, but because it operates at a sub-character level, it is capable of finding substructures that are not easily identifying by distance that work at the character level. So it should be used as last resort clustering method. So it also may more effective on longer strings than on shorter one. And thank you. That's end of my presentation.